Welcome to EDU World Space.
So in this video, we're going to work through problem 100 from chapter 20, which says nitrous oxide, or N2O, can be produced by thermal decomposition of ammonium nitrate. And here we have the equation for thermal decomposition of ammonium nitrate, which produces 1 mole of nitrous oxide and 2 moles, whoops, I copied this wrong, 2 moles of water. And we're asked what volume of N2O gas collected over water at a total pressure of 94.0 kilopascals and 22 degrees Celsius can be produced from 8.68 grams of ammonium nitrate. The vapor pressure of water at 22 degrees Celsius is 21 torr. So let's start with the information that we're starting with 8.68 grams of ammonium nitrate. So the molar mass of ammonium nitrate is 80.043 grams per mole. So the number of moles of ammonium nitrate that we're starting with is equal to the mass divided by the molar mass. That gives us 0.108 moles. And since there's a 1-to-1 ratio of the number of moles of ammonium nitrate that's being decomposed to the number of moles of nitrous oxide that's being formed, we also have 0.108 moles of nitrous oxide. So that's how many moles we're going to form of nitrous oxide. And we want to know what volume is that number of moles going to occupy. So let's deal with the pressure information that we're given first. So we're told that we have 94.0 kilopascals at 22 degrees Celsius for our total pressure. So our total pressure is the sum of our partial pressures. And the two gases we have are nitrous oxide and water. And you might be saying, but water was a liquid in that reaction. But we have the vapor pressure of water. So we have this equilibrium between liquid water and gaseous water molecules above the surface of the water. So we need to take that into consideration. So we're told the vapor pressure for water is 21 torr. So we want to convert that into the same units of pressure that we have for our total pressure. So in kilopascals, that's 2.80 kilopascals. So that's the partial pressure of water. And our partial pressure for nitrous oxide is equal to our total pressure minus our partial pressure of water. So that's 91.2 kilopascals, or 91,200 pascals. So now at this point, we know the pressure, we know the number of moles, and we know the temperature, and what we're trying to find is the volume. So now is a good time to use the ideal gas law, which tells us that PV is equal to nRT, where R is the ideal gas constant. So we're going to want to solve that for volume. So that gives us volume is equal to number of moles times ideal gas constant times temperature divided by pressure. So we plug in everything we know. And what we get out of that is 0.00290 meters cubed. But since there's 1,000 liters in a meter cubed, that's 2.90 liters. But let's take another look at the units that we have here for volume. So that's our final answer, is 2.90 liters. But let's go over our units. So we have moles times our unit for the ideal gas constant, which is joules per mole Kelvin, times our unit for temperature, Kelvin, divided by our unit for pressure, which was pascals. So let's go ahead and expand both our joules and our pascals into SI units. So our moles Kelvin and our moles Kelvin clearly are going to cancel with each other, but our joules are equal to kilograms meters squared per second squared, and our pascals are equal to kilograms per meter second squared. So our kilograms cancel and our second squared cancel, but we're left with meters cubed, which are equal to 1,000 liters. So that's how we ended up with this answer of 2.90 liters.